brainstorming different approaches to solve a problem is a really, interesting way of using a large language model, and one of my favorite uses for it. So something that I really like about large language models is that I can come up with a problem that I want to solve, and I can rapidly come up with different ways of solving that problem, and I can test them out and get feedback. Now, one way to do that is using the alternative approaches pattern. So the idea behind this is we're going to have the large language model within some particular scope always suggest alternative approaches for solving a particular problem or performing a particular task. That is, we always want it to give us good ideas. Now, I say good ideas, they may not be good, they may not even work, but kind of like brainstorming in a group. You may have a lot of different ideas, some of them may be great, some of them may be terrible, but just the fact that everybody's thinking through ideas, throwing them up on a whiteboard or writing them down or talking about them can help you, do a better job of thinking through the problem and figuring out what is the right solution that makes sense. So I'm going to show you how to use the alternative approaches pattern to essentially perform brainstorming with the help of a large language model. Now, one of the things to note is just like if you get a group of participants that have different backgrounds, they may help you come up with ideas that you yourself would not have come up with. Well, a large language model was trained on a big corpus of material, and it's probably seen lots of problems and seen discussions of different solutions to that problem or different alternative approaches for a particular problem. So you can think about it, it is in some ways learned information about how to solve problems in different ways and can help us get access to that knowledge. Now, it may also have never seen the exact problem that we're asking it for, and it may be able to synthesize, using what it's seen in the past, interesting potential approaches, even if it hasn't seen the exact problem that we're working with. So let's start off with an example of this. We're going to do the alternative approaches pattern. We're going to say from now on, if there are alternative ways to accomplish the same thing, list the best alternative approaches. So this is a very generic wording for this. It's probably better to structure it very, precisely to the task that you're working on, provide more rich sort of context. But I'm going to show you that even within a fairly generic wording, we can get this pattern to work for us. And then I'm going to say compare and I'll contrast the alternatives and ask me which one I want to use. So I'm adding a little bit to this pattern. I'm saying give me the alternatives, but also give me some information. Compare and contrast the alternatives. So maybe that'll help me, think through which one is going to better fit my particular situation. I can see if, what are the pros and cons of each approach and which one sort of is a better fit based on those pros and cons. And so I then ask it, if you think back to in some of the past videos, we've looked at using gameplay to create prompts and test us on our ability to write prompts. And so one of the problems that ChatGPT generated for us is it asked us to write a prompt to distinguish leap years. Basically, we would give it dates, and the prompt should be able to determine if it's a leap year or not. And so I'm going to turn that into a task for ChatGPT. So I'm asking ChatGPT to write several prompts for itself to solve this task. So I'm having ChatGPT write the prompts for me. Now, I could have introduced this earlier in the course and just said, any task that you have, you want to be better at prompt engineering, ask ChatGPT to do the prompt engineering for you. And that's basically what I'm doing here. And sometimes this works, but I don't want you to think that this is the best approach, that I should just always go to ChatGPT and ask it how to do it. No, you should have a sense yourself. Just like any problem you're bringing to a large language model, you have to own the content. So you should have some expertise in this area to help you distinguish what are the better approaches, what things don't make sense, what's unsafe or harmful in some way. You need to own whatever content comes out. So that's part of the reason I didn't just start by saying, prompt engineering, go ask ChatGPT for the prompt. We're not going to do that. But in this case, we are. We're saying we want ChatGPT to write a prompt to use few-shot examples to determine if a date in the year, month, day format is a leap year, and the output should either be year is a leap year or this is not a leap year. And so ChatGPT then says, approach 1, direct question format. In this approach, we directly ask ChatGPT whether a given date is a leap year, and then it shows us the few shot examples for doing this. So it's generating the prompt for us that we could provide, use essentially to go and check if something is a leap year. Then the second approach, it says conversational format. And then it uses a completely different sort of style. It's still roughly the same format of generating few shot examples to solve this problem. Now notice I scoped it to few shot examples. I could have left the scope more wide open and just said write a prompt to do this, but I thought it'd be fun to look at different, can we write the few shot examples in different styles and will it make a difference? And we could go and test this and see if it does. But we now see it generating, again, it's solving the problem of showing few shot examples for leap years. And now it's actually, I noticed something interesting. It's showing us how to solve the problem. It didn't actually fully follow the format that I gave it because I said, Y is a leap year, or this is not a leap year, and it is putting the date at the year at the front. So it's actually made a mistake, and this is part of the reason why you should read your prompts that it generates. So make sure they're doing exactly what you want, but I could go and tell it and fix it and refine it. But you notice now I've got two different approaches to few shot examples to solve this problem. And then at the end, I get a comparison. It says approach 1 is more formal and structured, making it easier to understand and parse. It may be suitable for applications where a clear and concise answer is required. And then it says approach 2 is more conversational and natural, making it more engaging for users. It may be suitable for applications where user interaction is important, which is kind of true. If you were going to prompt the user and then have here's what the user said, here's what the assistant's supposed to say, this would probably make sense. If you were just, reporting on a Q&A, then maybe the other format makes sense. So it's a reasonable discussion of the different alternative approaches for solving this problem. Now, let's look at another example. I thought, what is a task that can sometimes be burdensome? And so I thought about email. Now, I haven't actually done this and tried it out on my email. I still kind of keep my email personal, if I can, to my laptop, but I thought that this would be an enhancement in the future if I was running a large language model directly on my laptop, something like Llama or Alpaca, maybe I could do this and I would be comfortable with it. And so I say, whenever I ask you to write a prompt for me to accomplish a task, and I'm going to change the alternative approaches pattern slightly. I'm going to tweak it a little bit for this one. List what the task is, list alternatives for completing the task, and then write a prompt for yourself for each approach. So some basic format. Now I'm doing two things. One is I'm having it list the task at the beginning. So right here I'm saying list the task. And then I'm saying list alternative approaches for completing the task. So this is going to be up front. One, it helps me know what its approaches are going to be before I even see them. I can see a preview. Two, this can actually be helpful for large language models. If you have it kind of summarize the task and summarize different approaches or reasoning, this has been shown to be helpful in many cases. So I'm actually asking it to do that at the beginning, just to show you how you can tweak the pattern and get some possible improvements. In this case, it does roughly the same thing that we saw before. And then I ask me what I want you to write a prompt for. And so the prompt I ask it is I say, write a prompt for ChatGPT to automatically detect questions in a chain of emails and summarize everyone's questions as bullet points beneath each question. So the idea behind this is really, this key part is at the end, you can imagine getting behind on email and you want ChatGPT or some other large language model that you trust looking at your email, that you put it in the whole email conversation chain, assuming that you're following appropriate privacy and other rules around whatever content is discussed in that email chain. Maybe you start with something like what movie or what restaurant people want to go out to eat when you have like a group discussion. You get to these long group discussions and they've gone off the rails. People have discussed other things, thrown in jokes, commented on other people's jokes. And by the end of it, you can't really decipher who wants to go to what restaurant and why, because there's all this other random stuff thrown in. So you might go and say, summarize the questions and people's opinions on it, and it'll give you maybe just the discussion about the restaurant and people's perspectives. So you would dump this in, and I say, write me a prompt to do that. And so it gives me 3 different approaches. One, write a prompt that instructs ChatGPT to first identify all questions in the email chain and then extract responses related to each question. And finally, summarize the opinions as bullet points. Approach 2, write a prompt that asks ChatGPT to simulate a conversation where it plays the role of a summarizer. And notice it's basically using the persona pattern here in its own prompt for itself. Asking the user to provide the email chain and then generating the summary with bullet points. And then finally it says write a prompt that presents the email chain as a case study. That's an interesting approach. I wouldn't have thought of that. What's interesting is a case study, it probably read lots of case studies, so it's probably good at thinking about how do you think through a case study. And ask ChatGPT to provide a summary report that includes the questions and the corresponding opinions and bullet points. And then it gives me each of the different prompts. So ChatGPT, your task is to analyze the following chain of emails and identify any questions that were asked. For each question, please summarize the opinions expressed by the participants in the email chain as bullet points beneath the question. So it's generated its own prompt for itself. Prompt approach 2, ChatGPT, let's simulate a conversation where you play the role of a summarizer, and it goes on to discuss it, and then it has a slightly different format down here for how it wants things presented. And then finally, prompt for approach 3, ChatGPT, consider the following chain of emails as a case study. That's really interesting and a completely different approach. That's one I just would not have thought of from the beginning. Now, maybe if I went to business school or something, I would be more thinking of case studies and this is a natural approach, but this is something new to me, and so I can learn from how to write prompts. And now I have 3 completely different approaches that I could go try out without having to think of them myself. And I've also learned something, maybe case studies and presenting, different points of view on an idea as a case study is a good way to get output from ChatGPT. Now, what would I like to do next? Well, I'd like to take my alternatives and I would like to evaluate them some way. And one way to evaluate output, particularly when it's just text and you want to figure out how good does it look, does it seem to solve the problem, is just use the large language model to evaluate its own output or to evaluate the output of another large language model. Now, usually you want to do this in a separate conversation, right? You don't necessarily want to tell the large language model, now evaluate yourself. Sometimes that leads to worse behavior where it just says, oh, I'm right, Sometimes what we want to do is take that into a separate conversation and evaluate it. And I'm basically asking it, how would you write prompts to take your own output and evaluate it? How would you write prompts to evaluate the prompts? And so I say write a prompt to evaluate several different prompts for summarizing the questions in an email conversation and the different stakeholders' perspectives on the questions. And so then it gives me 3 alternative approaches again. Approach 1, write a prompt that presents multiple prompts to ChatGPT and asks it to evaluate each prompt's effectiveness in summarizing questions and stakeholders' perspectives. Approach 2, write a prompt that instructs ChatGPT to simulate a conversation where it plays the role of an evaluator and the user provides different prompts for evaluation. So again, using the persona pattern. And then write a prompt that asks ChatGPT to provide feedback on each prompt and suggest improvements of any. And so there's kind of a different take in each one. The last one is really about how do we improve each one. Second one is using the persona pattern to act as an evaluator. And the first one is really to evaluate effectiveness. So they're kind of different sort of takes on the same idea, but now I have 3 completely different ways that I could go and take my prompts that it generated itself and kind of look at, and evaluate them using ChatGPT itself. We're going to be faced with the problem with prompts of the large language models themselves are going to be moving very rapidly. They're going to be continuously evolving, and we've already seen that. We've seen ChatGPT and GPT-4, we've seen Llama and Alpaca, we've seen Vicuna, and lots of different ones are continually coming out. And one of the things we want to know is when we develop our catalog of prompts, our patterns, we put lots of work in developing prompts that work well for us. How do we evaluate them and make sure that they're maintained over time? Because if we change our large language model, does that mean that all of our prompts are going to break? Or if we change the data that we're working on slightly, does that have ramifications for us? So we need better ways of helping to evaluate the output. Now, one way, of course, that we're going to do this is we're going to have humans look at the output in many cases. but we'd like to do things that could probably help us scale better, be able to actually go and do sort of large-scale automated analysis in some way. So how do we go about doing this? Well, one of the really interesting things with large language models is we can actually use them to evaluate themselves. This can be one of the inputs that we use to help determine how good our prompts are and how maintainable they are over time, is we can use a large language model to grade either itself or the outputs of another large language model. So we've seen the examples of this where they've actually taken large language models and they've had one large language model teach another large language model essentially. But we can do something similar in that we can take outputs from a large language model and actually feed them back into the model itself to grade them, or we can actually go and take another large language model that we're working with and have its outputs graded by, for example, a better large language model, maybe with more parameters that has more powerful. So let's look at an example of this and how we might build a prompt to do it. So in this example, I'm going to teach the large language model, in this case ChatGPT, how to grade the output of a prompt. I'm not actually going to show it the prompt in my example. I'm just going to teach it the grading process so that it can help automate it for me. And so I'm going to use some few shot examples. So as input here at the top, I'm saying here's my input, and it's a bit of text about Vanderbilt University from Wikipedia. It identifies that Vanderbilt University was founded in 1873. And I explain, here's what the output was. The output was, the following is a list of events and dates in the output. Vanderbilt founded 1873. And then the explanation is that the output has unwanted text at the start and should only include the names and dates. And so I gave it a grade of 5 out of 10. So this is the output that was produced, and then I'm providing a human explanation of what is wrong with the output, of why it's not getting a perfect score. And then I'm grading it and giving it a 5 out of 10. So I'm going through and I'm doing a couple of these by hand to show it what I want. And then I'm giving it another example with that exact same piece of text. I'm saying the output was just 1873. And the point of this is that, if you can probably sense it by now, is I want a prompt that's going to extract events and the dates that the events took place. And that's it. I want an event name separated by a comma and then the date of that event. I don't want any other text. I don't want explanation. I just want names of events and dates. And I'm showing how ChatGPT can grade the output to see if it's matching that format. I'm not even showing it what the prompt is. I'm not showing it what the task is. I'm giving it examples to help learn. And then I say explanation. The output is missing important information about the event that happened on that given date. And I give it a grade of 3 out of 10. And then I have one more with the input, which is that same paragraph about Vanderbilt. I show Vanderbilt University, 1873, which is the ideal output for my fictitious task. And I explain that the output exactly, and then I actually cut it off. There's a typo here. It's really supposed to be met expectations or something like that. And then I give it a grade of 10 out of 10. What's interesting is this doesn't even matter that I made a mistake here in my explanation because it still works. And so then I give it a completely different input. I say, here's a different input. Again, it's about Vanderbilt and the history of the English program at Vanderbilt in creative writing. And so I give it as input another piece of text on that. I say the output was, and I give it what the output was, the fugitives and South agrarians, first half of 20th century. And then Vanderbilt is a founding member of the Southeastern Conference, 1966. And that's essentially a prompt for ChatGPT to then go and grade that output. And so it then provides an explanation of the output. It actually mentions something that I didn't grade in there, but it's interesting. It says there's inconsistent capitalization. And then it gives it a grade of 9 out of 10. So as a human labeler and a human performing this task, I actually ended up with a 9 out of 10 because I wasn't consistent in capitalization. But you can see it did a good job. It took the sort of substance of what I wanted and it performed the grading task that I had given it. And so we can actually use large language models to evaluate the output of prompts. Now there's a number of ways you could potentially use this. One is if you have some system that's going to go and make decisions or generate information with a large language model like ChatGPT or some other model that you're running, you might want to have the model check itself or another model check itself, or you might want to do this multiple times, where you take the output that you're getting and you give it a grading criteria similar to what I've done here, and you've developed a prompt with grading criteria. You might have multiple prompts with grading criteria, and you all have them score the output. And then if the score is below some threshold, well, maybe you want to have a human look at that output, or maybe you just want to retry it and see if you can get something better to be produced. And so this gives you an extra sort of tool of how do we go and evaluate what's coming out, make sure it looks good, and still have sort of the power and sophistication of these models. And this is one way to do it. Now, there's lots of ways that you could phrase the prompt. You might want to go and look at the alternative approaches pattern to develop some different ways. This is one example using few shot examples. Now, I could have gone back and say, we could have said act and use the persona pattern, act as a prompt critic, perform and give the output that I provide you a grade in terms of how well it matches the expectations of the prompt designer. I am going to give you examples of grading prompts. And so we could have gone and done something like that. I did a relatively simple prompt, but we could do a much more sophisticated prompt using some other patterns. Again, it's going to generate an explanation, and then at the end of it, it should generate a grade for us as well. And so it'll then go through and give us an 8 out of 10. So you notice we got 8 out of 10 one time, we changed the prompt slightly, we got 9 out of 10. Either way, it looks like that's a pretty good output based on our grading criteria and what we want. And so we can use this sort of tool in our toolbox. When we need to evaluate a prompt and the output of a prompt, we don't have to always fall back to having humans look at it. One thing we can do is we can fall back to having the large language model itself evaluate the output. And then we can build different types of automation around that, or we can use that as a trigger to escalate to a human. Now, of course, if we have a lot of really good examples of grading, that helps us a lot. But we don't have to have a ton. If you see in my example, I had just 3 examples of grading the output, and it did a good job of figuring out what I wanted. When we're having a long conversation with a large language model, sometimes we'll run into the challenge that the large language model will forget the rules of the game. It'll forget what we're trying to accomplish. What is the task that we're working on? And so one of the things we need is a way to remind the large language model, what are we doing? And we'd like it to remind itself if possible. And so the way that we can do that is by using what we call the tail generation pattern. And the idea behind this is that we're going to generate a tail, an end to the output that the large language model produces that will help remind it what we're doing. And so the tail is going to always be generated at the end of its output, and the tail will remind the large language model what the rules of the game are. And we're going to see this in the context of combining the tail pattern with the alternative approaches pattern and with the ask for input pattern. So we're going to put all these things together, and we're going to see how this is a really useful thing. So generating a tail on our conversation, using the tail generation pattern, is really, really effective in maintaining our conversation longer and maintaining the rules and the knowledge of our rules longer. So I've actually used this several times, and I haven't talked about it, but I'm going to show you what it does. So this is the prompt that I used in the alternative approaches pattern discussion. So I'm asking ChatGPT to generate a set of prompts to solve a particular task. So I'm asking ChatGPT to help us with prompt engineering. I'm going to give it a task, and it's going to generate possible prompts that we could use to perform that task with ChatGPT. Now, if I do this over and over, and I keep saying anytime I ask you for a prompt, you should go back and generate multiple alternatives for it, the problem I'm going to run into is that eventually it's going to forget that it's supposed to generate a bunch of alternatives and that it's supposed to be generating prompts. And so I need a way that keep reintroducing that rule into the conversation to keep it alive longer. And so one way I can help do that is with the tail generation. And so this is the tail that's being generated. I have the prompt and I say, when you are done, ask me for the next prompt to create alternatives for. So I'm adding this on. I'm saying when you're done, at the end of your output, you're going to ask me for the next prompt to create alternatives for. So notice what I'm doing. I'm actually using the ask for input pattern. I'm saying at the end of the input, at the end of the output that you produce, you're going to ask me for the next input. So you're going to ask me for the next task to accomplish. And I'm telling it, you're going to ask me for the next prompt to create alternatives for. So I'm also reintroducing the rules of the game. I'm describing what the purpose of the input is that I'm going to be giving it and what it's supposed to do with it. And I'm making sure that this shows up at the end of my prompt, at the end of the output that the large language model is going to produce. So I've defined the rules and I've said at the end of what you do, you're going to reintroduce this rule by basically asking me for the next input to create alternative prompts for. So let's see what happens. So I add this tail on. And so I'm generating a tail. I'm using the tail generation pattern. And I say, write a prompt for ChatGPT to automatically detect questions in a chain of emails and summarize everyone's opinions on the question as bullet points beneath each question. So I've given it the task. Here's what I want you to write me some possible prompts for. So I would give it the instruction. It's now going to write the prompts, and it generates a bunch of prompts for me, right? So now I've got all these alternative prompts, and then the last thing it does is it generates the tail, just like I said. So it says, please let me know if you have another task for which you would like me to write a prompt and create alternative approaches for. So right here, it's created a tail on its output. It's at the very end, and it says, please let me know if you have another task for which you'd like me to write a prompt and create alternative approaches for. You notice that its sentence that it's created encompasses a lot of the rules. It encompasses enough of the information about what it's trying to accomplish that we don't have to worry as much that it's going to forget the rules. And so then I go and I give it another task. I say, write a prompt to evaluate different prompts for summarizing the questions. And it goes through and it generates all the prompts, which we saw before. And then at the end, it generates the tail again. Please let me know if you have another task for which you'd like me to write a prompt and create alternative approaches. So we've got it to reintroduce the task again. And so now if we went in and we put in a new prompt, it still will remember what the context is. And if we went in and we had, back and forth without this, at some point it's going to forget the rules of the game. And it's going to say, hey, what am I supposed to do? Or it's going to forget to generate alternatives, or it's going to do something else. But by continually reintroducing the rules of the game as this tail on the output, then every time we go to send in a new input, just recently we had the rules of the game that give it the context that it needs to accomplish the task. So the tail generation approach is really, really useful when we're going to have a longer conversation, where we're going to try to program something. We're going to give it a bunch of rules up front, and then we're going to have a whole bunch of interactions, and we don't want it to forget the rules or the context. Now, it doesn't have to be rules. It could be anything that we think that needs to be reintroduced over and over into the conversation. And what we do is we just make sure that at the end of the output, we ask it to put in whatever that tail is. It could be asking for the next input. It could be, asking for some other additional information. It could be redescribing the rules. It could be kind of whatever you want it to be, but it's like a little nugget, a little tail that we're going to attach to that output to remind the large language model, here's what we've been talking about, and give yourself a little hint about it at the very end before we go on to the next task. Large language models really excel at working with text and understanding patterns of language. And a lot of times text is something that's really difficult to work with because we tend to have a human go and look at it to do a really good job of analyzing. Well, or we used to need a human to do that. Now we use large language models. But, going through and trying to understand text and manipulate text is one of the real strengths of the large language model. The next pattern is called the semantic filter. So this is basically a filter that can take in text and remove information from it or only keep information that has certain meaning or has a certain qualities that we specify. And so this can be a really useful pattern for a variety of different cases. Now I'm going to show it in the case of taking text and filtering out or removing certain things that we would like to get rid of from those texts. This might be secret information of some kind. It might be, removing things that aren't public. It could be all kinds of different things, or removing redundant information, whatever you need it for. But this is kind of a useful pattern in taking and manipulating text. So let's look at an example of it. So I'm going to start off with a very simple example of the semantic filter. And I'm going to say, filter this information to remove all dates and rewrite the text as little as possible to fix issues caused by the date removals. And then I've pasted in some information about Vanderbilt University from Wikipedia. And in this information, there's a whole bunch of dates. And so I'm creating a complex filter that's going to basically take in information, it's going to remove all the dates, and it's also going to transform the information a little bit to rewrite it, just in case I'm removing a date and it sort of makes a sentence awkward or there's obviously something missing. And so I'm going to take in information, I'm going to remove all the dates, and I'm going to slightly rewrite in order to do this. So I've got the Vanderbilt now Wikipedia information, and by using this pattern, which is to clearly say that you're going to serve as a filter, so we're going to say filter this information. So we're clearly indicating by saying filter that we want to preserve but remove. We're not trying to create new. We're trying to take in information and filter out or remove. So the pattern is basically, the semantic filter pattern is we're going to tell it to filter something and we're going to give it sort of rules, semantic rules about the meaning and what we're trying to remove, the meaning or the purpose of what we're trying to remove. So then what it does is it goes through and it rewrites all the text, and you notice that it does a pretty good job. It removes all of the explicit dates. Now, one thing I noticed is that I might need to go and rethink my prompt and how to express dates, because it says founded in the 19th century, and that might be too specific for me depending on what my meaning of date is. So I think it took a literal interpretation of it, like if it's a specific date. So if you go back and look, it originally said founded in 1873. So it removed the date 1873 and replaced it by rewriting it with founded in the 19th century. So it's actually kind of removing information, but I asked it to rewrite, so it's transforming it a little bit. But this shows you kind of the power. It's understanding the text, it's understanding what a date is, it's removing it, and in this case, we're also transforming it to rewrite it in some way. Now let's show you a more interesting example, and kind of where semantics and understanding of the meaning of things really gets used. So I'm going to say filter the information below to remove any information that would help someone figure out that the patient has diabetes. First, explain what information you're going to remove and how it might help someone figure out that the patient has diabetes. Then provide the filtered information. So what I've got below is a fictitious medical record that describes a patient, Jane Doe, has a number of symptoms. The patient presents to the clinic with complaints of increased thirst and fatigue for the past 2 weeks. History of present illness right here. Past medical history down here. Medications down here. Allergies, a variety of things. And then I'm going to actually have ChatGPT go into a semantic filter on this information. So now let's take a look at what it's going to remove. So it says, well, the chief complaint of increased thirst and fatigue should be removed because increased thirst, polydipsia, is a common symptom of diabetes. The history of present illness mentions increased thirst and not checked her blood glucose levels, both of which should be removed because they are related to diabetes symptoms and management. The past medical history includes type 2 diabetes mellitus, and I apologize if I'm mispronouncing this, which should be removed because it directly indicates that the patient has diabetes. The medication metformin, 1,000 milligrams twice daily, should be removed because metformin is a medication commonly used to manage diabetes. So this is taking the semantics of, I want things that could give away that this patient has diabetes. I want them filtered out and removed, so I'm giving some semantic rules about what type of information to get rid of. It has to understand to some degree the meaning in the text, or at least know, based on its training data, that these are things that are commonly discussed around diabetes. So one way or the other, it's figuring that out. And then it goes through and rewrites the medical record. And notice it rewrites the chief complaint be to the patient presents to the clinic with complaints of fatigue for the last 2 weeks. The patient reports that she has been feeling more fatigued. She denies any recent weight loss, blurry vision, or infections. Past medical history is rewritten. The medication is rewritten. And so now we have a filtering of what was here before. And so we notice that, like the history, it removed this. The patient reports that she has been experiencing increased thirst for the past 2 weeks. So we can use these large language models to develop sort of powerful semantic filters using the semantic filter pattern. Now, is it perfect? No. As we've seen, there can be, issues with it. And as we've talked about before, they're not always perfectly repeatable. But as a starting point to help maybe support a human process that then looks over it a second time, or to try to help prevent accidental release, it's just one more check in the system. This is a fairly low-cost check to try to remove extra things. Should it be the only check? No. If we're going to filter things out, particularly for privacy or other reasons that are where we have information that we don't want to get out, we should always have other checks in place, because this is not going to be a perfect filter. It's going to have some randomness. It's going to not always do exactly what we expect, but as a part of another process, as a component to help, it's a very, very powerful technique that we could potentially employ in parallel or in conjunction with other checks, other types of removals.